Hey people, and welcome to this video. In this video, we will be working on the Mathematics Paper 2, and this is for May-June 2026. Okay, as usual, the marks allocated is 150 marks, and we have 3 hours. Again, the rest of this paper will be on my channel. If you're only seeing this video and not the other topics that we have, okay, so the analytical geometry, the trigonometry, and the Euclidean geometry, is probably because it has been released only for members first, and then it will be released to the public. So to get early access, you can join my membership on YouTube and you'll be able to access the papers as soon as I post it. Okay, with that being said, this is going to be the statistics section of this paper. Lastly, just like I said in paper 1, I have resumed my online one-on-one tutoring sessions. So applications for those classes are still open, and I will include information about this in the description. So you can click the link in the description and you will get more information about those lessons. Okay, so with that being said, we look at our instructions. Just remember that diagrams are not necessarily drawn to scale, and we need to round off to 2 decimal places unless stated otherwise. Okay, I do not have the special answer book, so we're just going to wing it and see how that works out. And let's get into the first question, which is question 1. So question 1 says, there are 12 players in a cricket team. In a tournament, the number of balls each player faced and the corresponding number of runs each player scored are given in the table and the scatter plot below. So we have the number of balls, and that is X, and then the number of runs, which is Y. Okay, so this is what we have, and we know that the total of 12. So the first question says 1.1, calculate the equation of the least squares regression line. Okay, so we just need our calculator to do this. So on your calculator, okay, mine is going to be a little different, but on your calculator, just go ahead and press mode, and then you're going to go for the option that says stat. Then you're going to go for the option that says a plus bx, okay, so not the 1 VAR, because that's just one variable. We're going to go for a plus bx. Okay, with mine, it's over here in data and then here. Okay, now I still have info here. I have to delete that. Then you can go ahead and just put in these values. So your X values and your Y values. Make sure that you have 12 at the end. I know that on your calculator, the number that you're at is going to show. So it's going to show you like this is number 1, this is number 2. So just make sure you do end at 12 numbers for both rows. Okay, so let's go. Okay, and then once all of that is in, you are going to find the value of a. So remember that the equation of your least squares regression line is y is equal to a plus bx. Okay, so to find a, we're just going to press AC, shift and 1. And then you're going to get some options. It's going to be about 6 options. Then you need to go for the option that says REG for regression. Okay, so that's usually option 5. If you go for option 5, then you're going to see that you have a total of 5 options. So you want to go for the option that says A, okay? So when you click A, then you see that we get 39 point, and then round off to 2 decimal places. I'll just leave it at 47, okay? And then we need to get the value of B. So I need to erase this, but you don't have to. Then you just press Shift and 1 to pull up your info again. Go for option 5 for regression, and then go for B. And so B is equal to 1.4, and that's going to round up to a 4. Okay, so that's what we have. And so the equation of our least squares regression line is 39.47, and then we'll just say plus 1.44x, and that is our answer. Moving on to the next question. Okay, question 1.2 says, estimate the number of runs a cricket player who faced a total of 150 balls made. So you're just going to have to see the 150 balls, what does that stand for? Is that your X or your Y value? So you see the number of balls faced, that's X. And then these, the runs, are the Y values. So this is why they asked us to find this equation so that we can use this to make this estimation. So we're going to take this equation and we can see that what they've given us is an X value. So just substitute it in place of X. So in place of X, 150. And then you get your answer. So On your calculator, you can still do normal calculations. It's not going to affect the data that you have put in. So we're just going to find out what exactly that gives us. Okay, and so y is equal to 255.47. But then again, these are runs, okay? And so it's 150 balls. So approximately, this is going to be around 255 runs. I'm not going to say 256, of course, because if you round it off, it doesn't round off to that. And the 47 is not a full run, okay? It's 0.47. So that's our answer. Moving on to the next question. The next question, 1.3, says, calculate how many players scored runs, okay, that were more than one standard deviation above the mean. So we're looking at more than a standard deviation above the mean, but remember, this refers to the runs. Now let's just look up here. You see that the runs, these are our y values. So whatever you're going to find, it needs to be containing the y values, not the x values. Okay, so just keep that in mind. It's your y values that you're referring to. And let's see. They say how many. We just need to count the numbers, okay, the number of players that we'll have where their runs were more than one standard deviation above the mean. Let's understand what one standard deviation above the mean looks like. So you're looking at the mean and you're going a standard deviation above the mean. So that's the mean plus a standard deviation, a single standard deviation. For example, if they said 2 standard deviations above the mean, then you'd say mean plus 2 standard deviations, okay? But in this case, it was just 1. So this is a standard deviation above the mean, okay? Now, I know I said mean with the x values, but it shouldn't be the x values. Remember, we're looking at the runs, which is our y values. So I'll take the mean of the y values plus the standard deviation of the y values as well. Okay, so that's standard deviation of y values. That's specifically that. So we can find that first. So on your calculator, you're just going to, I have to remove all of this. You don't have to, you can just press Shift 1 and it'll work. So Shift 1, and then it's going to bring up that data again. This time you're not going to go for regression, option 5, okay? You're going to go for the option that says VAR. I think that's option 4. Okay, so that's here for me, variable. And then I'm specifically looking for the mean of the y values, and I want to add this to the standard deviation of the y values. So the mean of the y values, there it is, okay? It needs to have a line on top of the y. So that's what we have there. And that is 195.33 plus, and then we need to get the standard deviation of the y values. So again, Shift 1, then go for option 4, and then we're looking for the standard deviation. So standard deviation, that's what it's going to look like. And this is 101.8, and that's going to round up to a 4. Okay, so this is what we're looking at. Okay, then we still need to calculate this. You can still work with normal calculations. Okay, 0.33 plus 101.84, and this is what we get. We get 297.17. Okay, so what you're going to do here is this represents one standard deviation above the mean. You're going to look in your data, okay, look at the y values and check how many y values are more than one standard deviation above the mean, or more than this number. Okay, so let's go ahead and look for that. Okay, so here's our value, and we're looking at the y values, and we're just going to count how many would fall into this. So it needs to be greater than this number, more than this. That's not, and yes, this is above that. 350 is above it, and 388. Everything else is just in the hundreds and 200s. So no, it's just 3 numbers. Okay, so that would be our answer there. We would conclude, and you just have to follow what they say. They said, calculate how many players. So you're just going to conclude and say, these would be 3 players. Okay, so we see that 3 players had scores, okay, or the runs that were more than one standard deviation above the mean. Okay, question 1.4 says, explain why this point, so 95 and 350, the outlier does not fit the trend of the set of data. Okay, so why does this point 95 and 350, which is this point over here, so 95, yeah, okay, and 350, that would be this point here. Why does this not fit the trend of the data? Well, this is a scatter plot. So you know how we used to draw like the line of best fit? If you drew the line of best fit here, right, you will notice that the rest of the data, they're going to be close to this line. And so that shows you that they actually do follow the trend of this data. The reason why this would be considered an outlier is because it lies far away from this line. Okay, so it's not following the line of best fit, which would actually just show you the general trend of your data. Okay, that line is also called the regression line, and we have the equation of it. So we can just say because it does not lie close to or even on the regression line or the line of best fit. Okay, so I'm just going to say that the point does not lie close to or on the line of best fit or the regression line, and points that lie close to the regression line, they follow the trend of the data. So those points would be following the trend. Okay, so that is my answer for that question. And that is it for question 1. And moving on to question 2. We are now on question 2, and question 2.1 says, the marks as a percentage that grade 12 learners at a certain school obtain in the mathematics examination in June 2025 was summarized in the frequency table below. And then 2.1.1 says, write down the modal class, interval for the data. So the modal class interval. So we're going to just look for the interval that would have appeared the most, where there were more learners in this category, in this class. So you can see all through, there were learners who scored from greater than 20 to 30%, and then from 30 to 40, and then 40 to 50, and so on. And then these would be the number of learners that we can see here. So the interval that would have appeared the most, since we're looking at the modal class, mode, the number that appears the most, the interval that appears the most will be whichever interval has the highest frequency, whichever interval has the highest number of students here, or grade 12s here, which would be this one, So it would be this interval, and we'll just tell them this is where x is greater than 50, but less than or equal to 60. And that is our answer. Moving on to the next question. Question 2.1.2 says, complete the cumulative frequency column in the table provided in the answer book. Okay, I don't have the answer book, so I'm just going to use this as it is. And then let's just go ahead and put down a cumulative frequency column over there. Okay, so we are just adding up the frequency values. So with 8, we're just going to leave 8 here because this is the first number that we have. And then after 8, it's 8 plus 14, and then we have 22, so 8 plus 14, 22, and then 22 plus the 16, which gives us 38, and then 38 plus 21, which gives us 59, and 59, just make sure to use your calculator, just to make sure you don't make mistakes. So 59 plus 16, that is 75, plus 9, then we're going to have 84, and then plus 6, then that's going to give us 90, and then plus 2, that gives us 92. So there is our cumulative frequency column. Moving on to the next question. Question 2.1.3 says, draw a cumulative frequency curve, aka an ogive, to represent the data above. So we need to draw the curve. I don't have graph paper or the graph paper, so this is going to look interesting. Let me just see the numbers that we have here. We have 8 to 92. So I'm going to go ahead and just go in intervals of 4. 4 is a little too small. It's going to make this really big, but let me see what I can just use here. So this is what I have. I know it's a little too much. I feel like I should have just gone in, I don't know, 10s, but there's just too much in between numbers. That's how I was just like, like these two sets of ones in 90s. So I wanted to count in 4s and then 8s, but I just decided to count in 10s. So this is what we have, and let's plot. So we are first going to start like this. Just remember that you see the number that you have here. These are your x values. So all these x values, they're going to go with a y value, a cumulative frequency value. So with the first number 20, you're going to make sure that this goes with a y value of 0. So this is going to be 20 and 0. So 20 and 0, it's down there. And then you have 30. So that's 30 and 8. So 30 and 8 is just around here. So 38, just not by 10 yet. Okay, and then 40 and 22. So, I can just use a line so that I'm just making sure that they are in line. So 22 is just maybe a little above there. And then we have 50 and 38, and I'm just going to go ahead and fill all of these in. Okay, so it ends up looking like that. And then you're just going to join these. So just try to join them, and then it kind of looks like an S, something like that. Okay, so there we are. That's our ogive. And moving on to the next question. The next question, 2.1.4 says, use the cumulative frequency curve, the ogive, to estimate the median of the data. Okay, so to find the median using the ogive, this is how we're going to find it. We first need to find the position of the median. So the median is Q2, and I need to find the position first. So to find the position, we simply just say this is going to be, since it's the median, okay, this will be marked at half of your data set. And so you simply say a half multiplied by the total frequency, okay, the total number of students that we have, okay, grade 12 learners. Here, we know that we had a total of 92 learners, okay? So when we were adding up the cumulative frequency, we were trying to get the cumulative frequency, we were adding up the frequencies, we ended with 92, meaning there are a total of 92 learners here. And so you just say a half times 92, and then we get that. So that's going to be 45 plus 1, 46, right? And so we know that the median is going to be found at around learner number 46. So then we're going to go to our ogive, and we are going to go to the cumulative frequency. This is where the added up learners are. And we'll go to 46. Okay, so this will be 45 in the middle. 46 is just slightly higher. So I'll just lift that up just a little bit, like maybe there, right? And then once you hit the ogive, you're going to go down. Okay, so when you go down, this is what I get. It looks around 54, 55, somewhere around there. I'm going to say 54. So I'll say that Q2, okay, is around 54%. Okay, so this just means that half the learners got lower than 54%, and then the other half got higher than 54%. Okay, so that's what we have there. I'm just going to finally conclude that Q2 is about 54%, and that is our answer. Moving on to the next question. Okay, then question 2.2 says, the marks as a percentage that grade 12 learners at another school obtained in the same examination are represented in the box and whisker diagram below. Okay, so we're looking at a situation where they gave us an ogive and then a box and whisker diagram. So if it is given that the interquartile range, or the IQR, of the data is 45%, calculate the minimum percentage of learners who passed in this center. Okay, so the first half of this, they're giving you some info about the IQR. And just remember how to find the IQR. So IQR, right? We find this by saying Q3 minus Q1. This is the range of your quartiles. Okay, so the interquartile range. Like when you want to find the range, normally you say the range is equal to the maximum minus the minimum. But then with the IQR, it's the range of your quartile. So the highest quartile minus the lowest quartile. And so they give us this info. So let's just mark the quartiles quick. The quartiles, the box and whisker diagram, what this is telling you is your minimum value. Okay, so the lowest mark that was scored in this learning center, okay, was X minus 2%. So you see, we need to find X, okay? And then Q1, so a quarter of the class, they would have scored below whatever this mark is, okay? And then this is Q2, so half the class scored below this mark, and half of them scored above that mark, and then this is Q3 over here, and then that is the maximum. Okay, so let's see. what they're asking us to do is to calculate the minimum percentage of learners who passed in this center. Okay, so minimum. Okay, I get why they're saying minimum now, because we're using a box and whisker diagram, so you won't be able to find the exact percentage of learners who passed. So to find out the total learners who passed, that's really it. You can just kind of try to block out this word minimum. If you did that, then, and read it again, it says calculate the percentage of learners who pass in the center. Okay, so the lowest number of learners who pass in the center, that's really what they're asking, but as a percentage. Okay, which is fine because we don't know how many learners are at this center, but we do know how they are divided in the box and whisker diagram. So to find out the total number of learners who passed, here is how we would do this. Honestly, this question is a little, I don't know, I want to say it's a little ambiguous because they're saying the total learners who passed. I don't know what the pass mark is. Okay, I don't know if they're looking at this as a pass mark of 50% or it's a pass mark of 30%. I'm not sure. Okay, so maybe I'll just do for both. Okay, let's just see the info with the IQR. The info with the IQR, clearly they've given us this so that we can find the value of x, because look at what this is going to do. These are all in percentages, right? If you take Q3, which is 3x%, and then Q1, which is this, and you say it's equal to the IQR, which is 45%, that creates an equation to solve for x. So that's what they're trying to do here. So IQR, we know this is 45%. Q3, that was 3x, and then minus, and then we have that. Okay, I'm going to use a bracket here because I'm going to break these two up. It's really just going to be two terms, okay? 3x over 2 minus 3 over 2. So let's go ahead and solve for x in this equation first. So this is 45 is equal to, and we have 3x, and then of course if you break it open, so you can break those open and there'll be 3x or 3 over 2x minus 3 over 2. And so if you multiply that negative in, that's going to give you negative 3 over 2x and then positive 3 over 2. Okay, so that's what we get here. And now we're just trying to solve for x. Okay, so get the x's on one side and the numbers on one side. So these two, put them together. I mean, we can just use a calculator, it's fine. So I'm going to put my calculator back on comp and I'm going to say 3 minus 3 over, 3 over 2 is 1.5. So yes, it's still going to be 1.5. And so that is 3 over 2x. Okay, 1.5 is 3 over 2. And then you're saying 45 minus 3 over 2, which is 45 minus 1.5, 43.5, but I'm not going to do that. I'll just say 45 minus 3 over 2. Okay, so that's what we have, and I'll leave it as a fraction. Okay, so this is 87 over 2. So really what we have is 3 over 2x is equal to, and then we have 87 over 2. I'm just writing this side and this side. Okay, now to solve for x, do you see how they just both have a denominator of 2? Just times by 2 on both sides. So it cancels out that denominator, cancels out this denominator, and now you have 3x is equal to 87. Then divide both hand sides by 3. And finally, x is equal to, what is 87 divided by 3? That is 29. Okay, now I'm going to take these and I'm going to put them into these quartiles, just so that I can see the marks that was gained, okay, by how many amount of students or what percentage of students. So here's the thing. With the minimum, let's put that in. If you say x minus 2, okay, you know that x is 29. X minus 2, 29 minus 2 is 27. So the lowest mark scored was 27%. And then when we're looking at Q1, you just have to put x in there. Okay, so I'll just say 3, just put it as a fraction, 3 times, and then that is 29 minus 3, and then all over 2. And then that gives us 42%. So that's 42%. Okay, and then Q2, again, I'm just doing the same thing. So 2 times, I'm just going to put in 29 there, plus 5, just seeing the different percentages. We don't really have to find everything, but let me just try to make a point here. Okay, and then Q3 is 3x, so that is just going to be 87%. And they already gave us, the maximum was 91%. Okay, so with all of these, here's what we have. the question wants us to still calculate the minimum percentage of learners who passed in this center. When you're looking at this, it just depends on what the pass mark is. If the pass mark was 50%, so everybody who got higher than 50% would pass. Do you see that with the way a box and whisker diagram works, it divides the total number of learners into 4 segments or 4 parts. So 25% of the learners would be here, the other 25 are here, other 25 would be here, okay? And then the other 25, they are there. The only reason it looks the way it does is because we're looking at them based on their marks. So the percentage of learners, the minimum percentage of learners who would have passed in this center, depending on what the pass mark is, I will just create 2 scenarios. So let's say the pass mark was 50%, which I think that's really what they meant, 50%. I'm not sure because, the national standard is 30%, so not too sure about this. Okay, so the minimum percentage of learners who passed in this center, let's say the pass mark was 50%. So if you get 50%, you pass. So here's the thing about this. Do you see that at Q1, we have 42%, okay? So everybody who got below this, they did not pass. But then at Q2, you see that we have 63%. So it means that the learners who would have scored around, in the 50s and higher than 50s, right? Basically, they would be somewhere around here. I don't know exactly where, okay? But they would be to this side. So they will be somewhere here. Now, if you know that from Q2 all the way to the maximum, this makes up half the learners, 50% of the learners. But we can clearly see that the Q2 is marked at 63%, meaning there are learners who would have gotten 50% and maybe higher than 50%, but they will be like over on this side. Let's say they were here. Do you see now that the total learners who would have passed in this center, if the pass mark was 50%, do you see that there would be more than 50%? Because this is 50%, but then this is Q2, which is at 63%. Okay, everybody who got higher than 63%, they are over there. So we know definitely there are people who got 50% and higher than 50%. There will be like a small number of people. So there's clearly more than 50% of the learners in this center, okay, passed. That is if the pass mark was 50%. So if the pass mark was 50%, the total or the minimum, now you see that's probably where the minimum comes in. Because we cannot guess how much of a percentage these ones would be. We can't really see them since Q2 was already just marked at 63%. The minimum, the lowest number of learners or the lowest percentage of learners that we would have to consider is this 50% because we can tell them for sure 50% of them definitely got higher than 63% as we can see. So 50% of the learners would have passed this exam. Okay, I hope that makes sense because the question is based on the minimum percentage of learners who passed, okay, in the center. Okay, so if the pass mark was 50%, I'm saying that the minimum percentage of learners that would have passed would have been 50% of the learners because I can see that half the data set, okay, half of this box and whisker diagram, everybody got a mark that is higher than 50%, okay. Now, let's say the pass mark was 30%, okay. So if the pass mark was 30%, then we could look at it like this. The pass mark is now 30%. These are all the marks that they would have gotten in each of these quartiles. So there is 27%, but you see that at Q1, okay, Q1 we have 42%. So it means that everybody here would have scored more than 30%, okay? Because you see, they've scored more than 42%. That's way above 30%. So everybody here would have scored more than 30%. So when we're looking at that minimum number of learners, we would say it's the percentage that these blocks make up. These blocks make up this 25%. This is 25% of the learners, and this is the other 25% of the learners. Okay, remember, it's split according to their marks because this is a box and whisker diagram. So do you see that in total, that they make up 75% of the total learners that we have here? So if the pass mark was 30%, then you see that a minimum value of 75% of the learners would have passed. Okay, it makes sense that it's more learners because you lowered the pass mark, so more people will pass. Okay, so yeah, these are the two values that I'm going to give based on whatever the pass mark is. I don't know what the pass mark is, but that is going to be my answer if the pass mark is 50% and if the pass mark is 30%. Okay, so that is my answer there. And that concludes it for the statistics section of this paper. And I will see you guys in analytical geometry.